All right, level 3 says I can apply rules of positive and negative integer exponents. So it's probably going to start off pretty simple for you, and then I'm going to do a couple of examples where it's going to get a little bit difficult, okay? But we can do this. So we're going to rewrite each exponent with positive exponents, evaluate when possible. So what we're going to do is we need to make every exponent positive. The way you do that, if you think about it, is this. Okay, I'm going to go up to this gray box here. So when I have a negative exponent, I'm just going to write this off to the side. Okay, I'm going to do kind of a bigger example than the first one. So I have a to the negative second, b to the positive third over, let's say, c to the fourth. Okay, just one example. Okay, the b to the third and the c to the fourth are fine because those are positive exponents. The a to the second is not. So what we're going to do is we're going to take a to the second, and when it crosses the fraction bar, okay, whether you're going up or whether you're going down, that exponent is going to change. So the b to the third stayed on top because it was positive exponent. The c to the fourth stayed on the bottom, again, because it was a positive exponent. The a to the second has to move to the bottom, and because it crossed the fraction bar and moved, its exponent has now become positive. Okay? So anytime it crosses the fraction bar, it turns positive. It changes the sign of the exponent. So we're going to take a look at a couple easier examples. Okay, so looking at a, we have x to the negative 8th. So I'm going to put this over 1. Okay, the 1 is fine because it has a positive exponent. We don't even see it. The x to the negative 8th, that needs to change. So we need to cross the fraction bar, and it's going to go to the bottom. The 1 will stay there as well. And now, what's left on top? Since I moved the x to the negative 8th to the bottom, you think, well, there's nothing left. But there is. Whenever you think there is nothing left, there's always a 1 still there. Okay, just like we did on the denominator. When we think there's nothing there, there is. There's always a hidden 1 in there. Okay, so whenever you're like left with nothing on the top, there is always a 1. So please make sure you write that. And then all I'm going to do to simplify this is the 1 stays. 1 times x to the 8th is just x to the 8th. Okay? All right, moving to b. Again, we've got the 1 on the top, y to the negative third on the bottom. The 1 is fine. The y to the negative third needs to change. So it needs to go to the top, cross the fraction bar, and become positive. And now again, what's left on the bottom? Oh, there's nothing left. But wait, there's a 1. So there's always something left when you've moved everything around. And I'm going to simplify this. 1 times y to the third is just y to the third. Now you can keep the 1 on the bottom. That's fine if you want to. But we know that if I write this like 2 over 1, that's the same thing as writing a 2. Okay, so I can write this as y to the third. The reason why we couldn't do that in a is because we know that 1 over 2 is not the same thing as just 2 if I drop that 1 on the top. So you can drop the 1 on the bottom, but you can't drop the 1 on the top. Okay, it makes a big difference. Okay, letter C. Again, there's no denominator, so I'm going to make one. It's got 3 to the negative second over 1. So again, the 1 is fine in the bottom, so that's going to stay. The 3 to the negative second needs to change. It needs to go to the bottom so the 2 can become positive. And again, oh, there's nothing left on the top. Oh, yes, there is. There's a 1. Okay, so I'm going to simplify this. 1 over 3 to the second is 9 times 1 is just 1/9. Moving to D. Okay, what needs to stay, what needs to go? 1 can stay. 2 to the negative third needs to go. So it goes to the top. Exponent becomes positive. There's a 1 in the denominator still. So 2 to the third is 8 times 1 is 8 over 1. And I can write this as 8. All right, let's take a look at a couple harder examples. Okay, take a big deep breath. We can do this. We got this. Let's take a look at A. One thing at a time. So here's what I want to do first. I always try and simplify the numbers, the coefficients out in front. Now, negative numbers are fine. You can have negative numbers. You just can't have negative exponents, so the little numbers. So negative 12 is fine. We can keep that where it is. It can stay in the top. So if I simplify negative 12 over 4, that's going to be 3 over 1, and it's going to be negative 3. Now we're going to play a little game of should I stay or should I go? And when I say I mean the exponents. So I go base by base in the top and base by base in the bottom. So x to the 5th, that's going to stay because it's positive. Y to the negative 3rd, that needs to go because the y to the negative 3rd is positive. So it's going to go to the bottom and become positive. Z to the 0. Now, well, 0 is neither positive nor negative, but wait, anything to the 0 power is 1, and that's going to stay on the top. So now that they've dealt with the top, I'm going to work with the bottom. X to the 11th, that's positive, so that's going to stay on the bottom. Y to the negative 10th, that needs to cross the fraction bar, go to the top, so the 10 can become positive. Okay, so all I did was simplify things, and now I just need to take it one step further. I have negative 3, and times 1 is still negative 3, and I'm just going to rewrite all of this in the same order. The 1 on the bottom doesn't really matter because I have something holding it, so I'm going to write the x first, actually. So x to the 11th and y to the 3rd. Okay, now, remember when I told you that we subtract the exponents when we're dividing? Okay, I also told you to write it all out because this is the reason. Anytime before, our exponent on the top and exponent on the bottom. Okay, exponent on the top was always larger and it would always stay in the top. This time, our exponent in the denominator is bigger. So when you subtract the numbers, it is going to land where the larger exponent is. So I'm still going to subtract. I'm going to subtract 11 minus 5. So I always get a positive number. But the x will land in the bottom because out of these two exponents, the 11 is bigger. So again, you're still subtracting, and you can always write this out. You can write 5x's on the top and 11x's on the bottom and cancel everything out, and you'll see that you have 6 in the bottom still. Or you can just subtract the exponents, and the x to the 6th will end up in the bottom because x to the 11th was bigger than x to the 5th. Okay? Same thing with the y to the 10th and the y to the 3rd. You're still going to subtract 10 minus 3 to get a positive number of 7, and it's going to stay in the top because y to the 10th was bigger. So this is your final answer. Okay, B. Now, you notice that you have a negative second, okay, negative second power in there. Normally, we would write this twice. Instead, what we're going to do is we're going to take this whole thing, since this whole thing is to the negative second power, we're going to take this whole thing and move it to the bottom. Okay, just like we did if it was x to the negative second. We put this over 1, we're going to move x to the negative second to the bottom. Okay, it's the same thing, it just looks a little bit bigger. So I'm going to have a 1 on the top over 3x to the 4th, y to the negative 3rd to the 2nd. Notice nothing in the middle changed. It all stayed the same. So there were no exponent changes, there were no variable changes, there was nothing that changed. Okay, so nothing changes except for the 2 on the outside. Now I'm going to write this twice. 1 over 3x to the 4th, y to the negative 3rd, 3x to the 4th, y to the negative 3rd. Okay, so I'm going to simplify what I can. I have 3 and 3, that makes 9. X to the 4th, that's x to the 8th. and y to the negative third, y to the negative third, that makes y to the negative 6. Okay, that still works. You can still add those numbers together. But the last and final step is that we play the should I stay or should I go. The 1 on the top obviously stays. The 9 on the bottom stays. X to the 8th stays. The 8's positive. But the y to the negative 6 needs to go, and that's going to go to the top. So you can leave it like this, or you can drop the 1 since you have something else to hold its place, and write it like that. Okay, last but not least, when you have a fraction that's raised to the negative exponent, you're going to flip the whole entire fraction. So again, nothing inside changes. So actually, let's do this. Don't flip the whole fraction first. Remember when I said if you can simplify inside the fraction, let's do that first before we do anything else. That's what we're going to do. So I look inside my fraction. The 3 can stay, but the x to the negative 4th, that needs to go to the bottom and become positive. The 2 in the bottom should stay in the bottom, and this extra x should also stay in the bottom. And I'm going to write my negative 2 just in case I don't forget it. So I'm going to simplify, so 3 over 2x to the 5th. Okay, so now here's what I'm going to do. Since I'm simplified inside, this is going to make that the next step easier. So since this whole thing is negative 2, I'm going to switch this fraction, flip the whole thing, nothing changes inside, except the power of negative 2 just changed to a positive 2. So I'm going to write this twice, 2x to the 5th over 3, 2x to the 5th over 3. And I'm going to write what they have, what they're similar. So 2 times x to the 5th times x to the 5th. 3 times 3. So I have 4x to the 10th over 9. Okay, so again, anytime you have a fraction, simplify within, then apply the exponent on the top.